Again, my name is Urmila Sowell, and I'm the Technical and Advocacy Director for the National Glass Association. And I'm here with Lignell Consulting Services, that many of you probably know already. And today's topic for Thirsty Thursday is on edge grinding, safety versus aesthetics. So why is edge grinding being discussed right now? So before, we didn't have so many discussions about this. So to give you a little bit of background, there's growing interest in minimally supported glass applications. You're seeing larger lights. Architects and building owners want a nice, clean view without much metal interruption. They want larger pieces of glass, and so that way they can protect the view. Facades, skylights, interior partitions, and glass balustrades, they want larger and then without the metal. And but with that, you had tempered glass as your safety glazing of choice for many, many years. And a few years ago, we started to see some breakages in balconies. And so with these breakage, you notice that, the picture that you're seeing right now in Toronto, you have lights in balconies that are breaking and tempered pieces coming down. In Seattle as well, there were some in Texas and elsewhere. As such, the industry got together, and the International Building Codes in 2015, the glass railing code requirement was changed. So section 2407.1 of IBC 2015 now requires laminated glass in all handrails, guardrails, or guard sections. And it needs to be constructed of fully tempered or heat-strengthened glass and shall comply with CPSC or ANSI Z97.1, which is a safety glazing standard. There's only one exception. The exception is that if there's no walking surface beneath the risk of falling glass, so something, if there's a home on a cliff or something, or there's no possibility of anybody walking underneath the glass. So why did they go with laminated glass? Well, as you saw previously in the photo with the balcony, we need glass retention. So laminated glass is what's being used for its ability to provide post-breakage retention. With laminated glass comes exposed edges. Again, architects and building owners want to have the same nice, clean lines without the metal. And the expectation is the design and customers' requirements for the same high quality finish edges that they can consistently receive with the monolithic glass, this tempered glass. And as an industry, they're driving us to develop guidelines to accommodate these needs. So far, there's no such guidelines that currently exist. So the alignment of glass plies and the edge polishing before and after fabrication, and also the inner layer appearance comes into play with this. So exposed edge applications. So right now, heat-treated laminate with one or more exposed edges meet aesthetic requirements if there's a top rail, as seen in this photo here. Again, clean lines, but then you do have a top rail. So if there's a top rail on there, it's covered, so the laminated edges are not visible. So it's not an aesthetic concern. But when the edges are exposed, the alignment of the glass plies and overall appearance of the laminated edge are more critical to the designer and building occupants, especially those who pay, for a beautiful view with, off of a balcony, etc. So according to ASTM 1048, heat-treated exposed glass edges shall be polished prior to heat treating. So no after heat treating at all. So you cannot polish after. Industry currently has no generally accepted exposed edge tolerances to offer as guidelines. And what's in ASTM 1036, 1048, and C1172. I'll turn it over to Bill to kind of handle some of the applications here.
Okay, thanks, Urmila. Some of the things that we get into when we're looking at the different standards have to do with exposed edges, obviously, and many of the fabricators themselves develop their own techniques to do this, especially when they're trying to meet some of these requirements with regard to a very smooth and flat edge that architects are wanting. One of the things we find with laminates is that there's a very much in demand from the architects that these things meet certain edge alignment expectations. And what we also know is that there's standards that we have out there that's in place right now that give us the conditions for each glass ply with regard to its dimensional tolerances, both for rectangular and other shapes. And that's the ASTM C1172. And in Table 4, it actually shows us a lot of this with regard to the length and width tolerances and also the squareness tolerances. And these can be very critical when you're trying to line up two pieces or more of glass and a laminate. So some of these tolerances probably don't even fit the criteria that we want because they do allow certain things with regard to the cut shapes for different dimensional tolerances. One of the things that I also point out a lot to architects and other engineers is the minimum thickness range. I mean, for example, even on this chart, if you look at half-inch glass, the minimum thickness is 0.469 inches. And many of the float plants nowadays try to meet that criteria down to the minimum. And so if we go in and we start shaving some glass thickness off, either at the edges or on the surface, we may even be below that particular minimum. So let's take a look now at ASTM C1048, the standard that we have to use for heat strengthened and fully tempered glass. This standard also gives us a lot of guidance with regard to the fabrication of the glass and tells us what things we should look at prior to and after we do the heat treating. And what this technique does say is that we shall not alter the glass after it's been actually heat treated, because there is a possibility of a strength reduction. And I'll explain a little bit more of this when we go on further into the presentation. Actually, the fabrication guidelines that we get state that tempered glass and heat strengthened glass cannot be cut after the heat treating process. Also, they indicate that fabrication altering the glass surface thickness or edges shall be performed actually prior to heat treating to avoid reduction of glass strength. And this is pretty critical when you talk about the engineering aspect of it. When we do engineering of glass, we use that minimum glass thickness to do some of the engineering calculations and actually provide the engineering analysis for the glass. So if we're going to reduce that, then sometimes the engineer doesn't know exactly how thick the glass is, and he's already been designing it to the minimums. So when we look at heat strengthened and fully tempered glass, all the holes, notches, cutouts, bevels, and other things should be done prior to the heat strengthening process. Now when we look at also the ASTM C1172, which covers laminated architectural glass, this has a similar statement about fabrication techniques that should be done prior to heat treating. And there's an additional statement in there that also states, after the glass has been strengthened or tempered, it shall not be modified except as recommended by the fabricator. Now, we know that there are certain things that fabricators have to do once the glass is laminated. Sometimes there's got to be a little bit of trimming of the laminate if it does come out and become exposed around the edges. If it's going to be an edge that's going to be shown as an exposed edge. There's some minor alterations that we recognize that can be done, such as edge deletion or the logo application for things that we have to put on in many cases for complying with some of the standards with regard to safety glass. Here's a table that kind of shows what some of the things are allowed with regard to complying to the C1172. And as you can see, some of these mismatch tolerances are probably well beyond what would be acceptable for an architect or even a customer with regard to an exposed edge. So this is something that we have to pay very close attention to, especially for exposed edge conditions. And even the standard does say consult the supplier that you're going to be dealing with to make sure that you can determine what their capabilities are with regard to meeting the requirements that are desired for the particular project. So what about post-fabrication finishing? That's a situation where in many cases it does not comply with current industry standards, the C1048 and C1172. And as we mentioned earlier, and I highlighted some of the facts that it can weaken the glass. It's a situation where once you start to alter the compression layer on the glass that's already been heat treated with heat strengthening or fully tempered, unless there's been testing that supports whatever the glass strength is after that process, it's pretty much an unknown. And as engineers will tell you, they don't like unknowns. They like to know how strong their glass is. If the information that they're using from standards or tables or fabricators or manufacturers is given to them, they want to make sure that that's going to work in their application. So GANA and NGA has not endorsed post-fabrication finishing, and they've also got some of their glass information bulletins that give information regarding that particular subject matter. So what happens next? Looking at the photo in the upper right hand of this particular situation, you see a nice finished edge, and that's kind of what most people are wanting to see, and hopefully that can be accomplished without doing things to the glass in a post-finish type situation. Now, do fabricators post-polish and post-finish? Well, some do, and you know that's not in compliance with the standards, and hopefully those that do understand what their product performance is going to be in the future, and also with regard to how things are going to work in the application and the intent. Some of the concerns with regard to the post-fabrication thing. We do know that if you go far enough into the compression layer that you're actually reducing the strength of the glass. And if you look at what's going on here, this little diagram here gives an approximation of what that compression layer is and what the tension layer is once we heat treat a piece of glass. This particular section shows the compression and tension zones that would be pretty much estimated in some of the glass that's going to be laminated. The effects of certain things with regard to heat, cooling liquids, and polishing compounds also have an effect on glass. I've had some issues personally in my consulting business where I've had to go out and look at glass that was delaminating for various reasons, and some of it did point back to the fabrication and post-fabrication, which was done to give a nice smooth edge, but also some of the coolants and the heat that was done had some effects on the laminate in the sense that caused some problems, both aesthetically and structurally. So sometimes the glass strength reduction in a post-fabrication finishing process will not be in compliance with the normal standard that we use that gives references for glass strength and edge strength as found in ASTM E1300, the glass load resistance standards that we find for different allowable stresses that are used in the glass and even laminated glass. What we talked about with regard to how the residual stresses are developed, you'll see this compression layer that's approximately 20 to 22% of the glass thickness. And once you start to disturb that, then you get into the area of you're actually reducing the surface compression of the glass, and that in a sense also reduces the glass strength. Some of the things that we know about glass when we go through the heat treating process is that you have certain heat flows that cause the actual compression layers in the glass, and that goes through the heat treating process and then the quenching process that we have. We also know from some of the studies that have been done that there are conditions that there may be a little difference in the stress distribution around the edge areas where you get some tension layers levels that are very close to the edge. This happens due to the heat flow characteristics that occur during the heat treating process, where the stress distribution at the edge sometimes can look like the diagram that we're seeing right here. So Some of these things are important to understand, both in the concept and the fabrication methods that go on in heat treating glass. The cooling rate at the edge does differ from the cooling rate that's far from the edge, and this has to do with some of the thermodynamics and also the heat treating processes that are used. So there are some localized conditions that may increase the tension in the Y direction that we see here in the actual situation of the heat treating process. So you can get tension near the edge of the glass, and this is sometimes a critical zone with regard to what happens if we start to do some things with regard to post-finishing glass after it's been heat treated. Here's a couple examples of what happens during the heat treatment process and also the edge finishing condition. You see the one on the left, it's got pretty much a ragged edge, and this generally is kind of not acceptable in the field. It could have been a damaged edge, it could have been processed this way, but in essence, if it's an exposed edge, as was the case in this particular example, it's also somewhat of a dangerous edge. The condition on the right shows a nicely finished edge with very smooth edges, and using an exposed edge in a rail system has a situation such that most people tend to want to go up and put their fingers on it and go along it, and if there's a sharp edge, there's a possible injury condition, so we need to be very conscientious about that. There's a couple other conditions where we see some damaged edges due to the exposure of the edge. And this again was not a post-fabrication situation. It's a situation that probably happened either during fabrication, handling, or even delivery to the project. And here's an example of a fairly smooth edge that was basically fabricated to meet the requirements of the designer and the architect and customer that wanted a very smooth surface on their exposed edge. Here's an example of a condition where it does show that increased fabrication, and a post-fabrication situation shows that in this particular case, they took a little bit too much off the edge, and it caused a fracture of the one of the tempered plies on this particular piece of glass that was laminated and then post-finished with an undesirable result. I'm going to let Irma take over now and give you a little bit something that she's observed.
So on the screen right now on the left-hand side is a new product that I just now saw at the BC conference 2 weeks ago in Las Vegas. So what this is it's a laminated, excuse me, a laminated light of glass with a top edging. So it's an actual annealed piece of glass on top. And of course, when you see this, you still have the clean lines. It's just, if you look at the photo on the right hand side, you can see just a little bit of a line for the very top piece there. So it's trying to take care of the exposed inner layer there. So this is something that's coming out of Europe. I don't know if this is some a trend that we'll see here in the US, but I wanted to share this on today's webinar. So to kind of wrap up our webinar today, in a summary, it's laminated glass is being required by the building codes now due to its post-breakage glass retention properties. The exposed edges for heat-treated laminated glass will have a different appearance, of course, than monolithic tempered glass because you have two lights that are being laminated with an inner layer, so you need to really truly watch your alignment on this. And until the industry establishes an acceptance guideline or criteria where it comes to mismatch tolerances or inner layer appearances, etc., for heat-treated laminated glass using exposed edges, the glazing contractor and glass specifier should continue to discuss the project needs with the glass fabricator on a case-by-case basis and find out what exactly is necessary. The glazing contractor and glass specifier should first consult with the fabricator or supplier to discuss what's the best methods to meet the exposed edges for their aesthetics requirements, knowing that if they want nice, smooth edge, that they will have to have a certain way of laminating it a little bit better. Again, the industry documents, GNA's glazing guideline, as well as NGA, which merged, support the applicable ASTM standards. And until they are testing that goes on and shows how much is enough to grind down or etc., then we will not endorse any post-fabrication finishing of heat-treated glass. With that, we can open it up for questions.
All right, I'm going to mute you again. If you have a question, you should be able to unmute yourself at this time to ask a question. Otherwise, we ask you still remain on mute due to the feedback we are receiving.
I was adding that if you have questions for us, and unfortunately our audio is not working out for us today, if you have questions, you have our emails there, and of course we have the chat box as well.
Yeah, I think we've gotten a couple of questions. You should be able to unmute yourself, but I'm happy to read some of the questions that have come in through chat. The first being, based on what you presented, any grinding means non-ASTM C1048 compliance. Is that correct?
That's correct, yes.
Okay. Another question, is NGA working on a standard or acceptance criteria for exposed laminated edges?
Currently, we don't have that. When we gave this presentation at Fall Conference back in September of 2018, we did ask those in attendance if there's interest by the fabricators or suppliers for us to start looking into some testing. And I'll pose the question again. If there's interest for us to do this, please reach out to us. I think until we do have some testing information out there, all of the standards will still say that do this at your own risk, and we do not, it does not comply if you were to post-polish.
Okay, thank you. Another question is there any differentiation between grinding and polishing?
Grinding is usually the first step that you would do to start to reduce, say, the thickness or to make the edges match. The polishing is a second step where it goes in and redoes the glass surface to come back to the shiny, glassy finish that we have. So in most cases that we're talking about here, it's a two-step type situation. I mean, you can go out and polish glass, and this is done a lot just for removing, say, minor surface scratches. But even in some cases there, if things are desired to go in a greater depth, then you'll have to grind to get down to the level that you want to be. So it's a two-step process, and grinding is done first, and then polishing would be done second.
Great. Another question for you, Bill. Are you conducting a study to understand the strength loss of post-lamination edge grinding on heat-treated glass?
I do not have a study ongoing, but myself and some of my colleagues, we have put together what could be a test protocol to do this. I mean, it's a situation where you actually have to test glass with different levels of, let's say, surface reduction. I mean, you start with, a piece of glass that has no reduction, then you take a slight amount off, and then another amount off, and another amount off, and test those samples to determine, how much you could go and how much reduction you would get for a particular process. So there is not a study conducted that I know of that's actually given this information yet, but it certainly could be done. And myself and my colleagues, we have proposed some of this, and if it's needed by the industry, we can undertake a project to do some of this work.
Okay. Another question, I think, Irmela, going back to the photo you showed with the new product from the BEC conference, can the top part shown be UV applied?
I am not sure. It was a brand new product that was showcased. So once I understand a little bit more as to how they put it together and what the capabilities are, I can answer that question. Whoever had asked the question, send me an email, I can get back with you.
Just to reiterate, because we had a hard time hearing you, I think you'd be willing to email someone directly with more information on.
Yes.
Okay. Another question, does polishing mean non-compliance to 1048?
Well, not necessarily. I mean, polishing in many cases is to take out a minor flaw. And if you're grinding something, you're probably taking out a major flaw, or you're reducing something with regard to the edge, or doing something to alter the finish that was there prior to the condition that you're trying to do. So a lot depends on how much you're taking off. And most of the fabricators do understand this. I would say the sophisticated fabricators that have been doing a lot of work with regard to tempered, heat strengthened, and laminated glass do understand, you know, what they do. Sometimes polishing is a minor thing. To take out a scratch that might take the glass out of compliance with ASTM C1172 with allowed scratches. So polishing usually does not alter the overall surface to the extent where it could be a structural integrity thing, but there again, each one has to be taken on a case-by-case basis.
Okay, thank you. That's all the questions that have been received through the chat. If there are any more, there is another one actually. Let me ask this one real quick and then we will wrap this up for today. Is NGA, SGCC, and other organizations like that exploring any best practices as it relates to ASTM compliant post-polishing? This is currently a large bottleneck for fabricators.
Currently, I know that NGA within the glazing guidelines as well as ASTM said that we should not grind afterward.
Irma, sorry, I don't mean to interrupt you. Would you mind speaking a little closer into the mic?
Sorry about that. Is this better?
Yes.
Okay, so currently within NGA and GANA glazing guidelines, it does say that do not touch that piece of glass after going through a heat treatment process, unless there's any type of testing afterwards. You really don't know how much to allow or accommodate. So, like say for example, if you have a certain edge pressure, edge strength, and then you start to grind. How do you know if, grinding a millimeter is enough, or 2 or 3, or, more than that? And as, Bill had shown on some of the diagrams as to what happens to the glass during the heat treating process, you don't know how far away you are from that zone to where you'll get breakage. And sometimes, there's, I've heard of fabricators who post-polish afterwards, and it was fine and it got installed, and it may take 2 years or so, and then there will be breakage. And then there's others who've done it successfully, and it's been installed for many, many decades. And so it's until there are more testing done, I don't see us changing that. But where it comes to NGA or SGCC or any other organization working on this, it will have to be something that the industry, first of all, wants to do and be able to put forward, a test plan and support for it too.
Okay, there's one more related question and then another follow-up real quick. Just, I guess, confirming, there is post-grinding analysis protocol. Does that exist?
Not that I'm aware of.
No, not to my knowledge. I mean, this would be on an individual basis in a fabricator's shop, and they may have their own protocol, but it's not something that's published by any of the organizations, within the industry at this point.
Okay, and one more question about touched corners. How does that relate to edge grinding?
When you say touched corners?
Yes, touched, like in quotes, touched corners.
Well, if I'm understanding what you mean by touched corners, you might be taking a small amount off of what would be the point to make it something that's not as sharp or as blunt. And there again, that should be done post-fabrication or post-tempering, pre-tempering, I'm sorry, so that it's not affected by the tempering operation.
Great. One final question, and then we will call it a day. Would post-polishing affect adhesion on laminated products?
Well, that could be dependent upon, what actually is happening prior to. Some laminates like the tin surface, and if you post-polish too much, maybe you're disrupting that. So that again would have to be something that should be done experimentally and run some tests on to see how that would relate. There is a possibility that it could. Sometimes if there is a residue that's left by the post-polishing method and then laminated, I believe you're talking about heat treating it, then polishing it, and then laminating it. That could be an issue. Now, as I mentioned, I think during the presentation, there are some situations where the laminate itself can be affected by grinding and or polishing the edge with regard to the heat that may affect the laminate itself, and also the cooling materials that are used sometimes during the operation. This can possibly affect the laminate.
Excellent. Well, thank you again for Irmela and Bill spending your afternoon with us. Thank you to everybody on the call who joined, listened, and participated. Please take a look at the email addresses on the screen. If you have additional questions, I encourage you to reach out directly to Irmela and or Bill. As a reminder, we have another Thirsty Thursday coming up, third Thursday in April, and again, third Thursday in May. Keep your eyes on your email for more information on those topics and presentations. Thank you. Have a good day.
Thank you. Bye-bye.